Imagine you are a caregiver for your aging mother. You trust her doctors, but deep down you worry. What if something slips through the cracks? What if there is a hidden risk they missed? Now imagine you have an AI assistant, one that does not just guess, but carefully analyzes her medications, her conditions, and her treatments, and gives you a second opinion you can actually trust. In this video, I will show you how to build that kind of AI, not with code, but with a well-crafted prompt. You will see how we refine a single medical risk analysis prompt across 5 steps, make it accurate, consistent, and useful for doctors and for yourself. Hi everyone, this is Pedram, and you are watching Artificial Intelligence Unorthodox Lessons. Today I'm going to walk you through how to build a medical risk analyzer, step by step. A medical risk analyzer that delivers high confidence, trustworthy, and medically relevant results. We will start from a basic prompt and upgrade it in 5 smart steps, each designed to reduce hallucination and improve clarity. The final version, a prompt that helps doctors make safer decisions and patients understand their risks in plain English. Let's dive in. Let's start with the first prompt. I created these prompts beforehand for sake of saving time in this video, so I'm going to copy and paste it during this video. The structure that I used for this prompt was role, context, tasks. So I tried to be clear, but basics. The role is you are a medical assistant evaluating and analyzing treatment risks. So I define the role of GPT. Context. The subject is a 75-year-old female who is taking atorvastatin and has recently been prescribed to undergo severe physiotherapy or exercise sessions. And the task is, what are the top 3 risks, including both direct and indirect, for this subject? Let's see how GPT responds. So it responds and extract 3 different risks for me. Statin-associated myopathy, fall or fracture due to reduced physical resilience, and cardiovascular strain or ischemic events. 2 of them are indirect and 1 of them is direct. The thing is, the GPT is a probabilistic model. So each time that I run, I may get different results. So this is a very basic and simple prompt, but there are some issues around it. I have no quantitative confidence about this response. I have no idea about root cause of these risks. The model tried to give me some risk factors and explanation, but I did not define the risk factors properly in the prompt. So let's go to the step 2. In step 2, I add more explicit instructions and try to prepare for the probabilistic behavior of the model by a self-consistency strategy. Let me copy the prompt. In the prompt, the structure is the same, role and context, but task is different. I ask the model to answer this medical risk analysis question 3 times independently. what are the top 3 risks for this subject? The question is the same, but I asked the model to do this analysis 3 times. So I'm preparing for next step to aggregate this response and be more confident about my response. So after I ask GPT to respond to this question, it get me back with the 3 different results. As you see, the results can be a bit different. So myopathy here, or here we have dizziness or hypotension, which I did not have in the first attempt. And in the third attempt, I had cardiopulmonary overload, which I did not have in the risk analysis number 2. So as you see, the probabilistic behavior of GPT concludes to 3 different responses in 3 different attempts. I did this to have a better insights about the potential risks. So I tried to implement self-consistency strategy via multiple independent answers. And the goal was to reduce randomness and hallucination in this case. But how I can improve it? So in the next step, I add more quantitative metrics and try to aggregate response a bit better. Let me copy and paste the prompt in this step 3. So role is the same, context is the same, task is the same, but I ask the model to get back to me with a structured response around confidence, likelihood of occurrence, and health risks. I also ask the model to get back to me with the confidence in a scale of 0 to 10, and for the likelihood of occurrence is a scale of 0 to 10, and for the health risk in the scale of like low, medium, high. I use this scaling in order to be able to take average in the next step when I want to aggregate the results. Then I ask the model to answer this. GPT returns back with the more numeric responses, with the more quantitative metrics that helps me understand how confident GPT is about this response, or how what is the likelihood of the occurrence for this specific risk. So let me read one of them. So you see that in the first response, in the direct risk, you have a statin associated myopathy. The confidence is 9 out of 10, which is high. The likelihood of occurrence is 6 out of 10. So it means it's a little bit low, but the health risk is high. So model was confident about this response, and the health risk is high, but the likelihood of occurrence is not that high. So the question is now, should I be concerned about these risks? Model did the same structure for all of the risks that we have and for all of the attempts. So here I add quantification to deal with the uncertainty that we have with the model responses. A thing which is overlooked here is root cause analysis. In all the risk analysis solutions, you have to identify the root causes behind the risks. If you let GPT to do the root cause analysis by itself, it can do. But you better to guide it through this process and ask them to choose between these potential causes. In that case, it get back to you with a much more useful response. Let me copy and paste the prompt in step 4, which is in this step, I add this root cause classification. So the role is the same, context is the same, task is the same. The structure output have new field here, root cause. I choose this root cause out of all of the high-level risk factors in the medical context. For example, overall health. It means that maybe the risk is related to the age or to the overall health of the patient. Or drug-drug interaction or drug treatment interaction, and so on. So these are the very high-level risk factor in the medical context that I classify and introduce to the GPT to let it decide across these lists. So after GPT run and get back to the response, so it kind of should tell me that, for example, statin-associated myopathy, the root cause behind this is drug treatment interaction, which means atorvastatin as a drug interact with the treatment, which is a severe exercise or severe physiotherapy sessions. Let me see, maybe other, or let's look at the falls leading to injury. The root cause is a treatment condition interaction. Means the treatment is a severe exercise or physiotherapy sessions, and the condition is a person is a bit old, so is an age-related decline in balance, and severe exercise may create some risks. So this is also very important in all of the risk analysis. So here, if I want to kind of wrap up, I decompose the risk factors into an actionable list of root causes. And I try to guide physicians to understand these risks better with terminology that they are comfortable with. The last steps, which is also very important steps, I would try to aggregate this response and fully implement the self-consistency strategy and create the final answer. Let me copy and paste. So role is the same, context is the same, task is the same, the structure of the output is the same. But now I ask the model, find common responses across all 3 attempts and report them as the final response if the average confidence is above 8 and average likelihood is above 6. So this is a logic, a business logic that I add to the model to increase my confidence in this response, to build trust. I also ask the model to get back to me with the risk if the likelihood of risk is above 6, which means if it's basically the potential of occurrence is considerable, then report it to me. This is just my choice. And at the end, I ask, include average likelihood and your reasoning for the final response in both medical and layman's terms. So not only ask model to provide confidence, likelihood of occurrence, the level of risk, I also ask the model to get back to me with the reasoning. This is also something that I highly recommend you to do in all of your attempts. Ask the model to get back to you with some reasoning. In that case, you build more trust with the model and with the result, because you understand why the model choose this response, and you will become more certain about the answers. I also ask the model to get back to me with the final response in both medical terms, mostly related to the doctors, and layman's terms, mostly related to the patients. I want the patients and doctors understand this risk analysis to make sure both of them take benefit. And at the very end, I asked the model to show your chain of thoughts and intermediary results before presenting the final result. This is something which I am kind of emphasize more to be able to see all the process of generating the results, all the intermediary results. Sometimes, again, due to the probabilistic behavior of the model, GPT get back to me with the final result, which is not what I want. I want all the process and all the intermediary results. Let me run and see how the results look like. So as you see, for all of those 3 attempts, the model get back to me with the 3 risks, with the confidence threshold, likelihood of occurrence, the level of health risk, and the root cause. Model get back to me with the 3 attempts. Attempts number 1, number 2, and number 3. It creates a table and identify common risks across all of those attempts. And in the step 3, it calculates average confidence and likelihood for those common risks. And in a step 4, kind of select the final risks, which in this case, the only risk that have average confidence above 8 and likelihood above 6 and occur in at least 2 attempts is the statin-associated myopathy. And the model reports this as a final results. I went through 5 steps to enhance a very basic prompt and convert that to a strong analyzer that can help you analyze medical risk factors behind treatment. I want to one more time emphasize on the very details that the final prompts had, and take your attention to all of these details one more time, because I believe it is very important to pay attention to all of these details if you want to get good answer from AI. For example, if you may remember, I specify very clearly the context of the problem. 75-year-old female who is taking this medicine and going through this treatment. If you don't specify age, then the answer of the model can become very different, because age plays an important role usually in the medical risk analysis scene. So this is the first detail that I want you to pay attention. Define the context, define the subject status very well. I also structured the output of the model into the confidence, likelihood of occurrence, health risk, and root cause. If you don't define confidence and don't ask the model to get back to you with the confidence, basically you are clueless about how confident the model is for each response, which is not cool. If you don't ask the model about the likelihood of occurrence, you may end up to the result that it may be very important, but has a very, very low likelihood of occurrence, which means that it's likely not going to happen. The health risk, the level of health risk. There's a good chance that the model get back to you with a risk that has a high likelihood of occurrence with confidence, but the health risk is very low for that situation, for that risk factor, which means it may not be very important. Also, the same for the root cause. If you don't define root cause, you don't get the main cause behind all of these interaction, which is very important, because at the end of the day, you want to identify the risk and plan for the alternative solution. And if you don't know the root cause, you cannot plan for an alternative solution. So structured output, quantification, all of those metrics help you to shed light on the problem very well. I also add some guardrail, if you may remember, for this self-consistency strategy and for this risk analysis. Find common response across all 3 attempts, report them if average confidence is above 8, and so on. Which means that I want to deal with the probabilistic behavior of the model. I want to make sure that I put myself in a safe condition regarding this probabilistic behavior, using, for example, in this case, self-consistency strategy. I also ask the model to basically explain the reasoning behind in medical terms and layman's terms. I ask the model to get back to me with the reasoning. Why? Because I want to build trust. I want to understand why this results get generated. And I also want to read through it with medical terms and layman's terms to make sure I understand it very well. These are all details that if you want to get a good answer from an AI, you have to pay attention to. And obviously, if you run this model with different models in the OpenAI family, you maybe get different results. If you run it with the Grok, or if you run it with the Gemini, you may end up with different results. And the whole idea of building this model is make your final answer independent and basically insensitive to type of model, to each run of the model, and so on. Thank you very much for watching this video till this point. I provide this prompt from basics to the very end in a very descriptive document in my GitHub account. I'm gonna share my GitHub link in the comments below. So if you want to find out and try those prompts by yourself for your own problem, please feel free to click on the GitHub link and get all of those prompts that I spent time to generating it. Thanks again for watching this video. Hope you enjoy it and hope you learn it as well. Till next time, stay curious and don't forget to subscribe to my account to get notified with my next interesting lesson in AI.